Hello everyone, and welcome to your introduction to the Pythagorean theorem. So there are a few things that I just think are important for, smart, mathematically minded people to be able to do. And one of them is to be able to spell the word Pythagorean. So let's just take a look at it. P is P-Y, that's a hard part. Thag or Ian. Pythagorean. Pythagorean theorem. And you might be asking yourself, why does it have such a crazy name? Well, the reason it has such a crazy name is because there was a guy whose name was Pythagoras, who was Greek, and somewhere around the time of 500 BC, Pythagoras was the first guy who proved that this theorem was true. So someone else who we don't know is the first one who came up to this with this idea. But Pythagoras actually did a little calculations on pieces of paper which proved that it was going to work all the time. So that is why the theorem is named after him. Perhaps one day, if you persist in math, you will get a theorem named after you. All right, so let's talk about the Pythagorean theorem. First of all, it's a special theorem that only applies in certain cases. It only applies to right triangles. And a right triangle is one where two of the sides hit each other perfectly at 90 degrees. So one of them is perfectly across and one of them is perfectly down. That is a right angle. If you were to measure this angle, you would say that it is a 90-degree angle. That's another way that sometimes people refer to it. So here's an example of what doesn't work. This triangle does not work because this line is not straight up and down like it would be there. And this triangle does not work because, again, this side is not straight up and down. Neither is this side for that matter. So you have to have straight up and down lines. That's called being a right triangle. And the Pythagorean theorem only applies to right triangles. Okay, so let's take a look at a right triangle. Here's a classic right triangle. Now, I'm not getting out my ruler and measuring to make sure that that's perfect. So you're just going to have to pretend that you know it's perfect. This little tiny square in the corner is the way mathematicians mark perfect right triangles or right angles. So if you see that little square, then you know that you're dealing with a right triangle, which means you can use the Pythagorean theorem. Okay, so usually you label the sides of the triangle A, B, and C. It doesn't have to be. It could be X, Y, and Z if you want, but oftentimes you will see it labeled A, B, and C. And I don't care which side is A, and I don't care which side is B, but I do very much care which side is C. C is what is called the hypotenuse, which is another hard to spell mathematical word. Hypotenuse. Hypotenuse. And yes, you should know how to spell it because smart people know how to spell hypotenuse. Okay, so what is the hypotenuse? Well, the hypotenuse is the side that is directly across from your right angle. The side directly across from the right angle. And that is usually designated as C. Okay, so that is the hypotenuse. Okay, so now let's talk about the actual Pythagorean theorem. I will draw you another picture. This is another right triangle. And I will mark that it is a right triangle. And now you get to learn the actual theorem. Are you ready? It's not very long. a squared plus b squared equals c squared. That's it. That's the Pythagorean theorem. So if you have side A and you have side B and you have side C, if you know the lengths of two of the sides, you should be able to figure out the length of the third side. So let's do an example. So let's say that we are looking at our right triangle here, and let's say that we know two of the sides. Let's say that we know that this side is an 8, and we know that this side is a 6. These are inches maybe, or miles, feet, I don't know. But this is 8 units tall and this is 6 units long. Now already you might be objecting in your head. In your head you're saying, well, it doesn't look like that one's 8 units long and it doesn't look like that one is 6 units long. Yes, and that's what happens when you have a teacher freehanding the triangle. Don't be put off, just use the numbers that are given to you. Okay, so what we're going to do is we're going to solve to figure out how long our hypotenuse is. Remember, we know this is the hypotenuse because it is the side directly across from the right angle. Okay, so what we're going to do is we're going to use this formula, the Pythagorean theorem, and we're just going to plunk in those numbers. So A, we have 8. So this is 8 squared plus, and for B we have 6. So 6 squared equals, C we don't know, so we're just going to keep calling it C for now. All right, so get out your handy dandy calculators. A squared is 64. 6 squared is 36. Do you see what I'm doing? I'm just substituting those numbers in. Equals C squared. So the next thing to do is probably add those like terms, right? So we get 100 equals C squared. And now you can take the square root of both sides. So the square root of C squared is going to equal plus or minus the square root of 100. So C equals plus or minus 10. Now we can automatically rule out negative 10 as an option because we cannot have the length of a side be negative 10. So the correct answer, the most correct answer, is to say that C equals 10. And now we know how long our hypotenuse is. Let's do another example. Okay, in this example, I will draw another right triangle for you. And this time I will tell you that this side is a 3 and this side over here is a 5. And we do not know what this side is, so we'll call it X. Okay, so we're going to use our Pythagorean theorem to solve this. So the Pythagorean theorem is a squared plus b squared equals c squared. It is such a simple theorem, but it is so powerful. Okay, so remember our a and our b are any sides that are not the hypotenuse, and this one is the hypotenuse. So I'm going to put 5 squared over there because my hypotenuse has to be c, and my hypotenuse is 5 squared. And then I'm going to make the 3 either a or b. I'll make it a. We don't know this other side, so we'll continue to call it b. You could also call it x squared if you like. Okay, so we have 3 squared plus b squared equals 5 squared. So that would be 9 plus b squared equals 25. Okay, and just like always, we're going to solve for the letter. So we have b squared equals 16. That means that the square root of b squared equals plus or minus the square root of 16. So b equals plus or minus 4, but negative 4 doesn't make any sense because you can't have a side with a negative side, or a negative distance, so b is just going to equal 4. So that triangle is 3, 4, 5. All right, let's do, we'll do 2 more examples. Okay? let's do this one. This one, we have a right triangle that looks a little bit different in that it's very long, like this. However, we know that that is still a right angle because I tell you that. And let's say that we know that this side is 9 and this side is 40, and we are going to solve for C. That's our hypotenuse, right? That's the one that's directly across from our right angle. Again, I don't care which one you call A and which one you call B, but I care very much that C is always the hypotenuse. Okay, so our Pythagorean theorem says a squared plus b squared equals c squared. So let's fill in the numbers that we know. Here we have 9 squared, that's A, plus 40 squared, that's B, equals c squared, which is the number that we don't know, but we're going to figure out. So if you get out your handy dandy calculator, you get 81 plus 1,600 equals c squared. I know that's a big number, but don't be scared. You can do it. So we get 1681 equals c squared. I'm going to take the square root of both sides, and I get 41. 41 is the length of our hypotenuse. Okay? Make sure you put that in your calculator properly and make sure you get that answer. It should work out precisely to 41. Okay, let's do one more problem. This time, my triangle is kind of a reflection of the ones before. That is, my right triangle is over here on this side. And that just means that I have to pay attention so that I know that my hypotenuse C is over here now. So again, this could be A, or this could be B, or you could reverse A and B, but this one has to be C. Okay, so let's pretend like I know that A equals 11, and I know that C equals 61. Okay, how are we going to solve that? Well, we're going to write our Pythagorean theorem, a squared plus b squared equals c squared. And we're going to plop in these numbers. So here we have 11 squared, b squared we don't know, and c squared is going to be 61 squared. Oh, those are big numbers. Okay, but you get out your handy dandy calculator and you can get 121 plus b squared, which we still don't know, equals 3,721. Okay. So we subtract 121 from either side. B squared equals 3,600. You take the square root of b squared and the square root of 3,600. You get b equals 60. And that is how you solve for b. So the lengths of the sides of this triangle would be 11, 60, with a hypotenuse of 61. All right, that's it to working with the Pythagorean theorem. A squared plus b squared equals c squared.